Using moles. You should already have met Avogadro's number, 6.02 times 10 to the 23, which describes what is known as 1 mole, or 12 grams of carbon atoms. In this video, we are going to learn how to use moles to do some chemistry calculations. For any element, the relative atomic mass, or AR, is the weight in grams for 1 mole. When we compare chemicals, we compare equal numbers of particles, even though the weights are different. So we have compounds instead of atoms, it doesn't matter. So if we have compounds instead of atoms, it doesn't matter how many atoms are in the formula, only the number of compound particles. Let's say you have 1 mole of iron atoms, but they are in a compound, FeCl3. This means you also have 1 mole of the compound. The ratio of iron atoms to particles of compounds is 1 to 1. What is the ratio of chlorine atoms to particles of the compound? Pause the video whilst you think. 3 to 1. There are 3 chlorine atoms per formula unit. For any compound, the relative molecular mass, or MR, is the weight in grams for 1 mole, or 6 times 10 to the 23 particles. What if you had some Fe2O3 instead? For 1 mole of iron, you would have half a mole of the compound, because there are 2 moles of iron for every 1 particle of the compound. 1 divided by 2 is 1/2. You can have half moles of anything, or quarter moles, or hundredths of moles, because a mole is a really big number, 6.02 times 10 to the 23. 6.02 times 10 to the 23 can be broken down into smaller numbers, so it's okay to have fractions of moles. You can also double them to say that for 2 moles of iron you have 1 mole of compound. This is okay too, because the numbers are relative. How many moles of oxygen would you have in Fe2O3? Pause the video and think about it carefully. The answer is 3 if you're using 1 mole.